about the process.
The cladding of the dome is made up of 4 outer layers and in addition to 4 inner layers. Each layer is comprised of stars, what we call them stars, of different sizes. Together, when all the layers are put on top of each other, they form the rain of light, which is part of John Nouvel's vision.
The rain of light came about through years of testing and design work that was done in a mock-up prior to be putting onto the dome itself. And that took about 4 to 5 years, which a lot of you probably saw. It looked like a big pyramid out on here with the big name of the rain of light on the top of it. The design was done in Austria by Wagner Bureau, the dome contractor, with a lot of work back and forth with the architect AJN in Paris. The structural part of the cladding is aluminum extrusions. The dies were made in Austria and brought to the UAE for fine tuning. So they extruded the aluminum through these dies, and they have a stainless steel cladding that's configured into them. The stainless steel came from South Africa. Majority of the fabrication was done in the UAE.
There is one factory in Abu Dhabi that does the extrusions. After the extrusions, it goes to the second phase, which is the powder coating, to give the aluminium profiles the required finish as per the architect's vision. The third part of the fabrication stage would be the cutting and the assembly of the actual stars itself. Once this is done, the stars are delivered to site and they are prepared for installation.
The pieces range from 2 meters up to 12 meters in length, and from a few hundred kg to a few tons.
The cladding weighs 2,000 tons. The total number of stars are 7,850 stars for the 8 layers.
Each of the individual elements are unique, and they have a certain place to go on the dome. So it's a lot of coordination between the contractors and the fabricators. Piece 100 can't go in piece 103, so it's a lot of coordination and surveying done to make sure it's in the right place. The uniqueness of each piece gives the rain of light that's underneath. That's why they need to be in a certain position.
The underside of the dome is the more difficult one, because on the underside of the dome, what you cannot see right now are the massive platforms. It's not yet a free space. There are all of the temporary support towers that used to carry the dome before it was connected together. And there is no crane access. In addition, that here on the top layer, the dome cladding is resting on the dome structural elements, while for the inner cladding, it is hung from the steel structure. It's more difficult because you don't have crane access inside. So it's basically a manual job. Normally in any project we will have concrete and finishes and MEP, while here we have 5 challenges instead of 3 that you might find on another job. The 2 extra challenges we have are the marine works and the dome itself. The dome is the backbone, to me, it's the backbone of the project, because the dome is affecting the other activities. This is why we have to finish the cladding as soon as possible to allow for the finishes work and the MEP works and the marine works to finish. We devised with the contractor a method of installation that will allow us to work in parallel on the top cladding and the bottom cladding. There was a dependency before that one has to finish before the others, but we made them independent by using unconventional systems. The unconventional systems we're using safety nets to install the top cladding along with hanging scaffolds to allow us to work freely with the inner layers without any interruptions.
In early December, we lowered the dome into its final position, and that allowed us to take away a lot of the temporary supports that held the dome up. Now the dome is resting on the 4 piers. It's a big coordination. The coordination goes down to the finishes of the plaza as we take away all the towers that used to hold up the dome, now hold up the crash deck. And we're looking for second quarter 2015.